Hello CIS11. In this video I want to clarify how you need to test your input for Lab 4 exercise 1 and 2. Earlier I explained that you can put it to the register to test, but after you ran the program, what will happen is our register 1, R1 is always going to show -1. So you might not be able to validate it through the register, as the -1 just showed that the program is terminated at the end after it halted. So what we need to do is, if you have the program written, you're going to then go to the simulator and you are going to make sure that you initialize the machine if it's not. And then you're going to load the program. And before you run the program, you're going to use the set value button. And notice that in the exercise 1 program, your fill location for X is at 3120. That was in your code. And the fill location for Y is at 3121. So when you set your location, you simply put in hex 3120 for X, and you're going to give it a value. Let's say I give it a 5. Click apply. Then you can go to the next location, which is Y, where you fill for the Y. We're going to do hex 3121, and let's say I give it a 3. Okay, so in this program it's supposed to take X minus Y, so 5 minus 3, it should give you a 2. So once I set up my 2 input, I'm going to go ahead and click run. Okay, now notice up here, earlier we talked about how we can refer to the register, and it is temporary. So what you want to do is you are going to use the jump to option, and in our program we store it out to Z, and Z is supposed to hold whether 1, 2, or 3 in the case where 1 is positive, 2 is negative, and 3 is if it's equal to 0. So we're going to go ahead and jump to X 3, 1, 2, 5 is where Z would be. And in this case, it is a positive value, so Z shows that it is a 1. And that you can also see in R6. But if you're not able to set and see the value in the register, you need to go to the actual memory location that was used to fill for that label, because Z is going to store the value that's going to represent positive, negative, or 0. So in this case, we have 1, which is it's going to show positive value as we took 7, we subtract a 3, which gives us a positive value. So you can test it with different value in any case, but anyway, if you are trying to look at register 1 is always going to be negative no matter what at the end of the program. So it is important that we know how to go to the actual memory location. So if you go back and look where we set, so let's say that our X is 5, our Y is 3, and when you take 5, subtract 3, you should get a 2 as X minus Y. It stores to hex 3122, and then again you're going to take a look at each of the label and the associated address so you can map out whether the program is giving you the appropriate result. Okay, so again, like what I said, before you load your program, make sure you reinitialize the machine, load the program. After you assembled it, then you're going to use the set value, and we want to use the fill location for each of the label. So in this case, we're going to have X 3120 is where the X located, and let's say I wanted to put 7 for X. I'm going to go ahead and put in set in the Y value, which is at 3121. And in this case, I wanted to use 9 for Y. So after you set X and Y, we wanted to see if it subtracts and if it gives us the right output. So go ahead and click that. So here it does show the Y value in the register, but we can verify further, right, by looking at the address location. So go ahead and click on jump to. We're going to go ahead and put in X 3120 to go to that location. So for that X, it stores it as a 7. Y, we have it as a 9. So when you take 7 minus 9, it is a negative value. And keep in mind that these are hexadecimal. So what you can do is you can open up your calculator, put it into the programmer mode. You can put in the hex to check. So if I have 7 minus hex 9, then I should have my hex value is FFFE. So here is your result for X minus Y. And then for the output for Z, because it's a negative value based on the assignment, when Z is 2, that means it's negative. When Z is 1, that means it's positive. And when Z is 3, that means it's 0. So you can look at your values from the addresses, because register is going to be very inconsistent, as in some cases it would move out of the register, or register 1 becomes -1 after the program is completed. So I wanted to clarify this. I'm going to include this video in the lab along with the lab video, the full lab video that we have for today. And if you have any questions, please let me know.